Let's sketch the graph of the rational function g of x equals 15 over x squared minus 9. To start out, we'll look at some characteristics of the graph that we can identify from the formula for the function. First, it's nice to think about symmetry. We wouldn't absolutely have to do this, but if there is symmetry, it's kind of nice to know. So we want to determine if the graph is even or odd. And because the numerator is just a constant term, it's even. And because the denominator is x squared minus 9, it has even degree terms, it's also even. It only has even degree terms. So the graph overall is even, which is kind of a nice thing to know because it tells me that whatever happens on one side of the y-axis, the mirror image is going to appear on the other side. And we'll see that as we look at some of the other characteristics of the graph. So next up, let's think about the y-intercept. If we plug in 0 for x, we get 15 over 0 squared minus 9. So 15 over negative 9 is the same as negative 5/3. So that's our y-intercept, 0 comma negative 5/3. For the x-intercept, I want to solve the equation g of x equals 0, but we'll see in a moment this doesn't have any solutions because if we set a rational expression equal to 0, the only way for that to be a solution is if the numerator equals 0. So, trying to solve that, if I multiply both sides by the denominator, we end up with 15 equals 0, which of course is false. So there are no x-intercepts. So another important characteristic of rational functions are asymptotes. And so let's think about whether there are any vertical asymptotes. Vertical asymptotes, of course, come from setting the denominator equal to 0. X squared minus 9 equals 0. Well, that means that x squared equals 9. So x could either be plus or minus 3. And so we have two vertical asymptotes. X equals positive 3 and x equals negative 3. For horizontal asymptotes, we want to think about the degree of the numerator and the degree of the denominator. And it turns out that the denominator has the larger degree. And so when that happens, the horizontal asymptote is always just going to be 0. So let's sketch what we have so far and then plot a few additional points to see what the graph overall looks like. So our y-intercept was down here at negative 5/3, and we have a horizontal asymptote at 0, y equals 0, and a vertical asymptote at positive 3 and negative 3. And so to kind of think about a few other points, I'd like to mix some up and put some in all of these different regions, a little bit near to the left, maybe a couple in the middle. And here we can use the fact that it's symmetric across the y-axis. Right? We have this even symmetry. And so anything on the right side of the y-axis, the mirror image is going to appear on the left side. So I can really just focus on plotting a few positive values. So we can think about what happens when x equals 1. Well, then I'm going to get 15 over 1 squared minus 9. So 15 over negative 8. And at 2, the value is going to be 15 over negative 5. So that simplifies to just negative 3. On the other side of the asymptote, if we plug in, let's say, 4, then we get 15 over 16 minus 9, which is 7. And maybe we'll look at one more. If we plug in 5, we get 15 over 25 minus 9, which is 16. So let's see what happens if we plot those points. So at 1, the value 15 over negative 8 is a little bit less than 2. And at 2, we're going to be down at negative 3. Of course, the mirror image we know is going to happen on the other side of the graph. At positive 4, the graph is positive. It's up at 15 over 7, which is around 2. And at positive 5, 15 over 16 is a little less than 1. So it's getting smaller. Of course, the mirror image is on the other side of the graph, the other side of the y-axis. And so from those points, and we could plot a few more to get maybe a stronger sense of what's going on, but there's going to be a U-shaped, downward facing kind of U-shaped part in the middle, and then there'll be a swoop down and then flattening out to the right, and the mirror image on the other side, swoop down and flattening out to the left. So that's the overall shape of our graph. Again, this function was g of x equals 15 over x squared minus 9. I hope you enjoyed the video. Thanks for watching.